Welcome, everyone, to another edition of Building Tech Talk. And it's been a little while. So, to our 10 fans, I know you've been worried about us, wondering where we are, and we're back. So,
We appreciate the letters of
yeah,
concern.
yeah. The flowers were especially nice. But we are back thanks to some challenges with COVID and a lot of scheduling, and the fact that ZS2 Technologies strangely took off like crazy, and you guys have been insanely busy. That now we're just getting a chance to get back into the podcast groove. So, for those, if this is your first time listening, I'm Matt Stewart, your host, and we have our resident experts. We have Dr. Doug Brown, and we have Scott Jenkins, CEO of ZS2 Technologies. And today we're joined by someone we've been wanting to talk to for a long time, so long, in fact, that we brought him in permanently. But Terry Moser is the co-founder of IPB Systems. And IPB Systems is a really interesting story of a company that took a technology 20 some years ago that wasn't really mainstream yet, and you made a go of it for a long time and became one of the leading manufacturers and installers of structurally insulated panels. Is that correct?
That's correct.
So let's start. For those who don't know what that is, what is a structurally insulated panel?
Various products are made from structurally insulated panels. We were with the OSB on both sides, both skins. Structural means structural. Insulated means it's insulated. And panels are panels, and it's a sandwich. So it's got structural strength up to 20, 24 feet, depending on your building. In today's world, we got new products like ZS2 Tech Board. It's a tech panel. That's the interesting part of the future of SIP panels.
Okay, so let's review that again a little bit. So why would you build with a SIP? Why did you 20 some years ago? I think you said it was 26, but we'll call it 25 plus.
25 plus.
We did the
before we got
corrected.
going.
Actually, it's even farther back than that. I built a house prior to starting manufacturing, 1989. Panels came from Washington. And when I built that house, basement and walls, it just seemed the right thing to do because it's prefab, well insulated, and our heating bills were 60% less than the neighbors. So that technology has been around a long time. So, and why did I continue? Because every house I've moved, I think it's 19 times. Every one was a spec home. And it's hard not to live in a SIP house after you lived in a house.
So what had you looking for something different when you first went to look at that, to build that first house that you brought the panels in from the US? Why were you looking for something different in a home?
I like new technologies through and through. I was involved in the oil patch and did a lot of prefab manufacturing and processing. So we always brought our industry to the field, whether it came out of Calgary or Edmonton. And it was the same kind of concept moving forward. Because it would come in a truck, you unload, put it together. It's a puzzle. So,
Long time ago, you and I chatting over lunch, and you told me the story about living in 19 homes that you built that were spec homes.
Yeah.
And that always struck me when I first met Terry years ago as being, no, like he lived in the homes he built because they were better. They were quicker to construct, stronger, and far more efficient. It was just a better way to build. Like you lived your own value proposition.
And don't forget comfort, and don't forget air quality. So it's the SIP panel creates a airtight envelope, which then you control what air is coming in your house and going out. So, and that's what everybody's trying to get to today in our new building codes that are stick framed. So they're getting tighter and harder to build. In some areas, you're going to have to start wrapping with styrofoam and on and on and on, depending on their zone. And we still, 20 years ago, passed that. And today, we're even getting better. We got better foams, better sandwich, I guess you call it, and better exterior skins, which is ZS2. And we can talk about that.
Okay, so take us through the process, because in a way, you were in the very early adopting stages of SIP. So take us through the process of from when a project first starts, somebody has an idea for their house. How do they go through that process to build with a new, old, newish, oldish technology, depending on how you look at it? A newer way that most people aren't familiar with building. They are familiar with stick frame. They've seen those buildings go up like crazy, so they understand how that works. But for building with SIPs, how does that process go for the end user?
Well, the design doesn't change. They have their own architect or drafting designers. We convert our drawings to structural drawings, and that's where it starts. And then it goes in through the manufacturing process, and all the loads are calculated, and then we have to do the same turnaround as if you were in a truss system, which allows us to get it in our manufacturing queue and get it out, because the walls go up before trusses. So it's really, the process is a prefab fabrication of walls, and that's been around a long time. So,
and this is fully engineered. That's
fully engineered.
That's the key. Like this is structural, hence SIP. So the engineers, you work very closely with our structural engineers to make sure everything's exceeds code.
So Terry, when you're using a structurally insulated panel, I'm just thinking about wood prices and how they've increased so dramatically during this COVID world. Are you able to use less lumber? Is there a lumber savings?
There is. I mean, you can engineer your building or your house to remove more lumber through our standard design. We've got a standard design which got approved through CCMC or NRC. And then you go through each municipality if you want to start pulling out lumber. Savings wise, yes, you remove lumber. Installation wise, it does not change. So, but again, it goes back to the client, giving them that option. So, like our panels and ZS2 panels, you lose maybe 10 or 15% of strength if you start removing the lumber, which again, the charts are quite, axle strengths and wind loads and transfers are quite high. So it doesn't really affect the building. That's our responsibility through our designers, where to go from there. And we get a lot of clients especially British Columbia. They want to go as green as possible. So why would you not start removing? It's just a less thermal bridging across the wall.
And to be clear, if you're removing some lumber and reducing the structural strength a little bit, that's okay, because these panels are 30 to 40% stronger to begin with than stick framing. So I think that's what gives you some of the flexibility.
I'm going to correct you. They're over double.
Over double. There we go. So, I'm kind of a, under promise, over deliver guy. So.
Yeah. So, I mean, with all the amount of projects and mostly all the testing we have done, and now jointly doing it through ZS2, we're gaining more and more education or design concept of getting things better out there.
So Doug, that's something you've been looking at, and that's really where this came about, that we started talking with IPB and started looking into this technology, is a lot around the testing from your perspective as a scientist, and looking at the opportunities that exist for a better building, a stronger building. What have you found looking into the technology behind SIPs and applying that to your research with magnesium products? How do they work together?
Yeah, absolutely. Well, one of the things that's dramatic is the thermal bridging aspect, as you said. So the code in 2021 has changed now to reflect thermal bridging of even steel. So a lot of these superstructures of steel are having a hard time using that in the insulation layer. And from a residential standpoint, the 2x4s that are 16-inch on center, if you can space those, 24 or 48, you're removing a lot of the ways heat can be lost in your building structure. So from an energy efficiency standpoint, it's a hugely beneficial opportunity. The also the benefit is from a ZS2 standpoint is the fire rating. The fire rating potential of the tech board is enormous. So you have that working in your benefit as well. Yeah.
Interesting. So, Terry, when you started building with this technology, then why didn't everybody just drop stick frame, run out, and just do nothing but SIPs after seeing how well it worked?
That's a real good question, because that's when we decided to build the plant. We thought that would just, you build it, they will come. It's not that simple. People don't like getting out of their ways of how to build. They're used to. Large builders, they don't like changing their scope, their process, because then it's more managing. We've trialed 2 or 3 large companies and same thing. They just didn't want to change how they process. We got into SIP manufacturing and modulation at the same time, and we dealt with modulars. We got two modulars, house modulars, built through some large companies. And when they were building the SIPs, they get to the framing stage, and then they have to pull the house out and move it up about 4 or 5 levels because it's done, not going through insulation, vapor barrier, all that stuff. So it disrupted their line. So you actually had to have a modular line that works well for SIPs. And in the US side, guess what? They're doing it. They're starting up those lines, and that's what they do.
Well, I think because you and I have both toured a lot of these modular builders, and
Yeah.
we know many of them well and count some of
Yeah.
them as good friends, but they're still building using conventional materials. Yes, in a controlled environment, but those 4 or 5 steps you just mentioned that you're skipping with a SIP panel, that was throwing them for a loop in their production line, because they're still building framing, insulation separate, electrical separate, sheathing separate, putting it all together, and then they're shipping a big box of air. So they're kind of just one step ahead of building on site.
Yeah. So on the one plant, they actually moved it outside to finish it because it was already locked in. Like, that's the advantage. If you did a SIP wall, SIP roof, put your windows in, you're sealed up. You can actually heat the place. So that's the advantage of the north in your short window of building time. So,
well, and what's interesting, we've been having some really interesting conversations with our partners down in California, Arizona, New Mexico, Nevada right now regarding a whole bunch of projects, Texas with Red Sky. And of course, for them, it's not savings on the heating costs, operational efficiency. It's how do we lower that air conditioning bill because of the premiums and electrical prices skyrocketing. This is, of course, for California and our Oregon partners, independent of course, the fire safety and life safety aspects of integrating the tech board with IPB's SIP panel technology. So if you think about the operational costs, and a few heat waves happening right now, and what does it cost to cool that space, those living quarters?
It's large.
It's
actually,
a lot.
when we did the condos, townhomes actually in Mexico, they were putting in 5-ton units for their block concrete block system, and we went to a 10.5, and we still cooled faster than they did. That was just the change. The other thing I guess we missed on the advantage of the tech panel or the SIP panel is it's just not the insulation value that creates energy savings. It's the envelope being tight. We used to belong to the Energy Star Association through the U.S. SIP Association, and when they came to talk about energy savings, it always was twofold. Thicker the insulation is helpful, but air loss is the other 50%. So it's 50-50. So tighten your envelope, you get your energy savings, and then of course then your insulation.
So can you explain how you get that tighter envelope through using SIPs versus stick frame?
It's just how the SIP is installed. It's nothing normal than what we would do on a SIP site. It's the way it goes together. It's a male-female connection, and it's tight. Like it's just the way SIPs operate.
So they lock together tighter.
They lock together.
Okay.
Yeah.
And so you don't have those air gaps or Doug, is there some advantages with the types of because not just using the insulation, but the way the panels work that in your testing that you've seen creates that tighter envelope?
Yeah, absolutely. I mean, if you're comparing against, let's say, the sort of lowest standard, which is bat insulation, I mean, bats are notorious for settling, or, installers cutting corners because maybe they just ran out of a bat on this particular wall. And having a dead space of insulation is essentially having a hole in your building envelope. So you can have dramatic heat losses, even worse than thermal bridging, because there's just nothing there. And so that's one of the things a foam prefabricated solution gives you, is that you have that sort of certainty that, hey, anywhere there is a joint, it's all spray foamed and expansion foamed together. And so it's all extremely tight. It's kind of a double-edged sword too, though, because you do need to monitor sort of air quality inside and outside to make sure there is enough air exchange, because you don't get that natural sort of breathing of the building anymore.
No. There's real good HRV systems out there, right up to 98% efficient if you want to pay for that. But majority of them is about an 80 to 85% exchange, but that means whatever comes in, you lose 15% going out. So that's not very much. No. And that technology has gotten better over the years, and that became part of the National Building Code about 6 years ago, which in this area, nobody was putting them in because they didn't understand it. Now it's part of the code. So because it's proven to get better air into your home.
Well, and we were talking earlier a little bit that the codes are changing throughout North America. We've seen it with Title 24 in California, British Columbia, the STEP code. As an example, we work on a potential project in Kelowna, British Columbia. Effective June 1, they moved from Step 1 to Step 3. Yeah. So for those building with conventional materials, your costs, not just material costs, have gone up, but now to meet these new standards are going up exponentially. So it's a double whammy. But the truth is the SIPs and SIP construction has already, from day zero, exceeded these standards. Yeah. It's already there. So it's becoming not just cost competitive. We're seeing from some of our potential clients, it's becoming cost compelling to build with this technology. Yeah. It makes so much more sense. Independent, again, of the life safety, healthy air, all of the other benefits, comfort. Yeah.
Yeah. And if I could add to that too, I would say the National Building Code has finally caught up to sort of the energy efficiency standpoint, but I would say it's still fairly far behind on resiliency to, storms and fires, as we've seen pretty recently. And so, the solutions that we're seeing today, which is wrap your building in 2 inches of foam, is sort of maybe the alternative to a SIP, might not be up to code, in 10, 15 years from now. You might have to have all those foam layers, sandwiched between something. Yeah. So SIPs might be leading the edge again here in 15 years as a solution using cement boards. Yeah.
And then it also becomes an architectural question where your membrane or your vapor barrier is when you start wrapping outside foam. Where is your vapor barrier, on the outside or is it in the middle of the wall? So it's a tough one. So the SIPs, it's a solid vapor barrier, so you don't have to worry about it.
And then in terms of construction, like your history, and I don't even know how many projects you and the team at IPB have done.
Probably 1,800, 1,900 tested or built or designed too.
Yeah, 1,800 projects under your belt. So a few. You've got some experience in this field. But in terms of, delivering those projects and the speed and just simplicity. But what's impressed me as we've gotten to know each other over the years is these houses, these buildings. We joked and sent out a little note on social media about the building down in Cypress Hills for the provincial government. It's beautiful. It's gorgeous. These are all custom. They don't all look the same. This is the architects and the designers and the clients have complete freedom of design. Yeah. And then we build to what they want, their dream.
Yeah. There is optimization, but not much. You just design the way the client wants it is the optimum.
Do you think that's maybe one of the misperceptions that took place over the years when it came to SIPs, because they are pre-manufactured? Is there a perception that you're just going to get a box, like a modular, like that you just get what comes off the line and you have to take what you get? Was there a little bit of that uphill battle when you were trying to explain to people why they should be building this way?
I would say a big portion of them were like that, thinking there's only one way to build with a SIP. But we've done some beautiful homes and pretty neat buildings, like the Cambridge Bay project. That's going to be a hexagon. so that's a neat building, right? So again, with the amount of background with our designers, what we built to and the strengths, there's lots of opportunity out there, and height. Don't forget structural. So as other products are, there's limitations. So you just design around the limitations. For a steel building, we'd have less steel in the building versus if they're just doing a normal steel. So we take advantage of where we can.
So with a little bit of, I'd say, slow adoption from the building industry on your technology of using SIPs, what were some of the things that you were trying to get them to understand as far as why, as a builder, not as an end user, but as a builder, this is advantageous for their business and for them to be looking into this as an opportunity to build their business?
I think I would call it stumble. It's probably the word I would say. I'm technical design, and then my partner was more hands-on sales. We were weak in the marketing side. So once we got a builder involved, we got several builders that build with our product. There was no going back because they seen the savings. The material was more, their labor was less, and the advantage to do it. So it was probably lack of knowledge for them, understanding. So we needed a group. We needed somebody like Zetas to see where the next step is, because this technology is old, is not new. I know when the first engineered trusses came through, it took over 20 years to actually people started using it. So the industry's slow and changing over. We have good results in the U.S. because it's more widespread. They got more manufacturing in there. So they grow 40 to 50% of product a year. So Canada had optimum of lots of trees and stick frame, and this is what we're going to do because we did it 35 years ago. My dad's house, when we built it in early 70s, I think it was, it's built the same way as they're building it today, 2x6 with insulation. So that's a long time ago.
In some ways, that house in the 70s might be built a little bit better.
It might be. Well, they went from 2x4 to 2x6 in that one spot, that one time. Yeah.
So you mentioned labor savings for builders.
Yeah.
Why do they need less labor to build a house or build any building with?
Well, less labor. It's hard to find real trained labor, and then to keep them is the other thing. So we have a handful of framers that we can send out with the product to build it if the client elects us to frame it for them. So,
but the nice thing is those crews are a lot smaller than a typical framing crew, and they're trained by us.
Yeah. And even yesterday, we were on a project for training just to put up the owner's training on site. There was one person that was a framer, and the rest were all laborers, and they got their basement done basically in a day. So, I mean, it's a puzzle. It's not difficult to learn. We just need to get them on the right track when they're on the site.
So it's less skilled labor required in order to build a building, more of general laborers, and it sounds like fewer of them than you would normally need.
We would always send somebody out to train if they've never certified through our group, right? So again, do it right. And that's like any other product, or,
And access to skilled labor, in construction is becoming the number one issue. We hear about it definitely in the United States. I think in Western Canada, maybe a bit of a reprieve the last few years, but it's getting tougher and tougher to get those trained, whether it's carpenters, framers. So if you can reduce the number needed, but the good news for those that are the skilled carpenters, framers, builders, they actually get to be leading edge once they learn to build with us, which is so easy. And they can do a lot more projects. It actually becomes very profitable for them.
That's a benefit for the bigger builders. It wasn't our study, but studies have been done that if you just bought SIP walls, you'll get one house out of 10 paid for by the labor of savings. So if you're doing 100 houses, that's 10 houses that were built through the prefab system. And it's not, it's SIPs, but we're talking prefab too as well. So
really builders can boost their volume because they can build them faster with fewer guys, and you're still doing the labor savings. So it just seems like there's a lack of crunching the numbers on the business side of builders to look at faster and better ways to do this. And then they would have a unique selling proposition for their buildings at the end of the day. So
their challenge is where does that start and stop? Like, you can explain it to them, but their spreadsheets or how they price is a little bit challenging to them. And as they get more educated about their savings and doing one or two trials, then they'll see the benefit.
And I've thought about this a lot, and chatting with Doug and Terry and Greg up in Port St. John is, for builders in the construction industry, especially home builders, it's a low margin business. So if they can make a couple extra points on something, amazing. But worse, in reverse of that, is the fear of doing something new and it not going well. And so losing a few of those points when it's a low margin business. Like, these are volume builders, right? They make up for the low margins in volume. So there's this fear of anything new. So for us, I think our focus is finding those true believers, spending a lot of time holding hands, but also those builders that they're not just building one house. They're going to be, and so we're going to be with them the entire step of the way. And we see it with Moline Homes in particular, and all the projects that are coming in the door now. And it's just getting faster, more efficient, and the clients are getting a far superior product, far superior.
all right, just to wrap up here on this topic with Terry today, I think having seen this technology come as far as it have in the 25 plus 20,
you have to do
however many we're talking, what do you see next? Because it is such, it was such a leading edge technology back then. It still is, because it hasn't been widely adopted. But where can it go from here in your mind? Well,
volume's the key. Volume will suffice. Like, again, it's like any product that you make. As we grow, clients grow, get their projects done in an efficient fashion. That's how I see it. Like, back to where we were at is great manufacturing. We were looking for volume, and where we were located in Fort St. John, we always had that risk of being so far away from the main where places we could sell to. So our market.
So it's scaling now, making it more widespread and widely adopted.
Yeah. And if you looked around of the large projects or large SIP plants in the US or even Europe, there's a lot of volumes going through there. So, and volume is going to be a ZS2 product. It's a better panel, right? So,
excellent. Any closing thoughts, gentlemen, on SIPs?
I think the future is bright. Like, as I mentioned before, if we start to factor in resiliency in a lot of these things, I think SIPs make a lot of sense. If they're going to help mitigate your flooded basement or some sort of forest fire that moves on through, or house fires neighboring. Maybe that's a game changer as well.
The mold, we forget about the mold, bug resistant. It just goes on.
Termites,
yeah,
etc. I think from my perspective, the goal at ZS2 is to develop innovative technologies. So the tech board, so the fireproof, and then integrating that with the SIP panels from IPB Systems, partnering with IPB, Western Canada's leader in SIP panel manufacturing, but also with Terry as partner, Greg, their team, having them now as the partners and part of the ZS2 family with over 1,800 projects. I think also that's what gets me excited is, the leading edge tech, but also combining it with all that building prefab construction experience. That's kind of the secret sauce right there. So taking what's old and making it new again is what I would say.
Excellent. All right. Well, thanks, gentlemen. That was a good conversation about some upcoming technology and some exciting things happening, and hopefully a little bit of inspiration for some up and coming builders to look at some new options to build their businesses. So thank you for listening to Building Tech Talk, and we're going to be back out with our bi-weekly regular podcast
We're
now.
back.
So tune in more often and subscribe on iTunes and wherever you get your podcasts. We're on Spotify and YouTube, so be sure to ring the bell, subscribe, all that good stuff that everybody does, and we'll be catching you next time on another episode of Building Tech Talk.